Hey guys, welcome back to our second video for AP Chemistry. And again, this is going to be mostly a review video that you should have a good grasp of this knowledge, but we still need to make sure that we understand it. So we're talking mostly about matter today, and this will finish up our first chapter in our book. And we need to know that the definition of matter is anything that occupies space and has mass. And it also is going to exist in three states that you already know. You've got a solid, you've got a liquid, and you've got a gas. In terms of solids, they are very rigid, they have fixed volume, and they have a fixed shape. Now, a misconception about solids is that their molecules don't move. Something that we need to be aware of in AP chemistry is that the molecules of solids, they actually do move. So the way that we describe their movement is that they vibrate. Solids vibrate, the molecules go back and forth a very, very tiny amount. Not enough for you to see or even to feel, but it does happen and we need to be aware of that. If we're talking about a liquid, liquids have definite volume. They take the shape of their container, and then gases, they don't have a volume or a shape. It takes the volume of the container and it takes the shape of the container that it is put into. And we also need to know that gases are highly compressible. If you take an empty water bottle, you're able to compress it into probably about half the volume just by pressing on it with your own hands. So you can easily compress gases. Here's just an example of the three states of matter. You have ice, which is obviously a solid, and you can see that the molecules are arranged in a very particular order, and they are very close together. But remember, they do vibrate back and forth. They're not just motionless. Then if we look over at liquid water, the molecules are spread a little bit further apart. They're freely able to move wherever they want within the liquid. They can't leave the liquid, but they can move around wherever they want within the liquid inside its container. And then if you take a look over here at gas, you only see two tiny little particles because gases are spread extremely far apart and they can move anywhere they want within their container, and they move at very high speeds as well. So gases move the fastest, liquids move fairly quickly, and then solids hardly move at all. They just vibrate in place, connected to one another. Now, there's a couple different ways to classify matter. We have mixtures. Mixtures have a variable composition, meaning they have different compositions, and they can be separated into pure substances by a physical means. So we can separate them rather easily compared to a pure substance. Now, a pure substance is our second classification. So we've got mixtures, that's our first classification. We have pure substances, that's the second classification. And that's a substance that has a constant composition. Mixtures have variable composition, pure substances have the same composition. The two different type of mixtures, we can break them down into a homogeneous mixture and a homogeneous mixture all looks the same. You cannot distinguish one part of the mixture from another part of the mixture. Examples of that would be air, wine, or brass. If you think about air, there's 7 different gases that are commonly included in the composition of air, and some of those would be like oxygen gas, carbon dioxide gas, nitrogen gas, and so on. You cannot see those different gases in the air, but they're all there. You breathe them all in, and you breathe some of them out as well. But you cannot see the difference, so that would be a homogeneous mixture. The other type of mixture would be a heterogeneous mixture. These are mixtures that you can see the difference of. And that would be something like sand and water. You can see the sand floating around in water, or maybe it accumulates all at the bottom, but it is still a mixture. There's still two different things that are combined together, and you can see the different parts. Another example would be iced tea and ice cubes. You can see the ice cubes floating around in the iced tea, and so that would have two different parts, and you can see the differences in the mixture. Now let's take a little second here to see if we can figure out which of the following is a homogeneous mixture. So which of these looks identical, but also which of these is a mixture. If we think about pure water here, water, you might think well, it all looks the same, and you would be correct about that. You cannot see the differences in water. However, water is not a mixture because it's all water. You have the same thing there. There's no two different parts to water. So this one would not be a homogeneous mixture. This would actually be qualified. Oops, let me get my pen back here. This would be qualified as a pure substance. So it's not water. And you can see here the answer already popped up on the screen, but let's go through the other two really quick, or the other three at the bottom. A jar of jelly beans, you can see the differences. That one's easy. So it's not homogeneous, it would be a heterogeneous mixture. Same thing with soil. You can see the differences. You can see worms and rocks and different sizes of soil pieces, so that would not be a homogeneous mixture. And the last one down here, copper metal. Copper would be an element on the periodic table, and since it's on the periodic table and it's only copper, then it's not a mixture. It's just that one thing, so that would also not qualify, which leaves us with our last thing here, gasoline. Gasoline is composed of a bunch of different parts, and it's hard to see the differences in gasoline. If you look at a container of gasoline, it would all look the same, and so we would qualify that as a homogeneous mixture. The next thing that we need to talk about would be a physical change. And physical changes allow us to change the form of a substance, but not its chemical composition. The most common mistakes with physical changes would be boiling or freezing water. It is very common for students to think that boiling water would be a chemical change because the water is going from a liquid to a gas, and so they think it changes the chemical composition of the water. Or same thing with freezing, it's going from a liquid to a solid, so they think it's a chemical change. Get that out of your mind right now. Anytime, it doesn't have to be just water, any substance that boils or freezes or melts or goes through a change like that, it's going to be a physical change. When water boils, it just goes from liquid water into gaseous water. So it doesn't change to something different. It's still water. And because it's still water, that means it's going to be a physical change. Physical changes are incredibly useful to separate our mixtures into their components. But it limits us. We can't actually break those compounds into elements. So we can separate the mixtures, but then we can't separate any further from there. We can get the pieces, but we can't break the pieces down into the individual components that make up the pieces of our mixture. So the most common ones that we will be using, and we'll talk about these more in class, and we're actually going to go through a little mini lab day, and maybe we already have by the time you're watching this video, but we're going to talk about distillation, filtration, chromatography, boiling, and freezing within class, and we're going to go through examples of how these can help us separate our mixtures. And these would all be physical changes. Now let's talk about pure substances. These are compounds or elements with constant composition. Now, if you don't remember from your regular chemistry class, a compound is just a couple elements combined together, like water would be H2O. That would be something called a compound. And pure substances have to have our constant composition throughout. So if you have a glass of water, it's all H2O. It's all the same throughout the entire glass of water. There's nothing different anywhere in that glass of water. Compounds, though, we can break down into their individual elements with chemical processes. So you can break down H2O through a chemical process into the hydrogen, into the oxygen that make it up. Those would be the two elements that make up water. Elements, however, they cannot be broken down into a simpler substance by a chemical or physical means. They can be broken down into protons, neutrons, and electrons, but not by a chemical process and not by a physical process. That requires something different to break it down further. Chemical changes. This is a change that gives new properties to a substance. So you're changing what actually the substance behaves like. It could be something that is hard, and then it goes through a chemical change, and then it's going to be very soft, or it's going to change colors. There's a bunch of different ways where we can go through chemical changes to yield different chemical properties. An example that would be on the screen here would be a Bunsen burner reacting with oxygen to form carbon dioxide and water. That's just burning the gas, and it creates a new compound, two new compounds, carbon dioxide and water, and that would be called a combustion reaction, which we'll talk later about in the year. Another thing would be mercury and iodine combining through a chemical change to produce mercuric iodide, which you can see the two up here. They will combine and form this substance down here, which is completely different than what they were when they were separate. It has new properties, so it's gone through a chemical change. Just to review a little bit here, you've got matter at the top of this chart, and this is a very useful chart to keep all of this information straight. You've got matter at the top that is composed of solids, liquids, and gases. You can break matter down into two categories, pure substances and mixtures. You can combine pure substances to create mixtures, or you can use different physical methods to separate mixtures into pure substances. Your pure substances can then be broken down into elements and compounds, and your mixtures are broken down into a heterogeneous and a homogeneous mixture. Now just one last thing here. How many of the following are examples of a chemical change? Well, a chemical change means we need different properties. The first one would be pulverizing rock salt or crushing salt. That would just change the size of the salt. It would not change the properties of the salt. So our first one would not be the correct answer. I did not mean to do that there and give you the answer. The third one down there, dissolving sugar in water. This one is a little bit tricky. You may think that because you're dissolving the sugar in the water that you're changing the properties of the water because the water is now sweet. However, that is not the correct way to think about this. When you dissolve sugar in water, that just means you've got some sugar mixed with some water, and nothing has changed. The sugar is the sweet part, the water is the liquid part, and so that is not going to be a chemical change. Melting a popsicle on a warm summer day. Remember, when something melts, like when I said an ice cube melts, that was not a chemical change. That is still a popsicle, it's just in a liquid form instead of the solid form that you're used to, so that would be going through a physical change. And so we would be left with burning of wood. When you burn wood, those ashes are left with completely different properties than the wood itself before it was burned, and because it has new properties, it has gone through a chemical change, so that would be the correct answer. That's it. Thanks for watching this video, and I will see you guys in class tomorrow.